Okay guys, listen up here. So today is the last day of moles and chemistry. And tomorrow I will do the formal unit exam review in class, okay, where I go over a few things, take questions from you guys and tell you about the questions that will be on the test. Okay, obviously it's very much like the practice test, you already have some idea, okay, of what that's going to look like. But you get the most out of a review class if you come with questions. So if you have already been doing some review and there's something that you're not sure of or you would like clarified, tomorrow would definitely be the day to ask that. Or any day if you come in for help. Okay, would also be fine. So make sure you're taking advantage of that. I totally misjudged when your exam should be, but I'm not moving it because I already said it would be the 19th, so it's staying on the 19th. But we'll have like 4 days of bio in place before we even do the test. So just know that we will be starting biology on Friday. Okay, that stuff, anything that's bio will obviously not be on the caption exam. Okay. All right, we got 4 mole equation questions on the board. The last 4. Okay, so let's see what you remember. Because I know you practiced this a lot over the long weekend, and so you haven't forgotten any of it. So you're going to be done these like that. Okay, so this is the easiest one because we're just looking for how many moles, which is N. Okay, so that's our question mark. It tells us the mass, 65 grams. Okay, and it tells us the substance, water, which is nice because that one's easy. And we don't have to drop and swap that one really, and we just know what it is. So H2O is going to mean that's hydrogen, there are 2 of them, plus 1 oxygen, 16, going to give us a molar mass of 18.02 grams per mole. Okay, now that we know that, now we can use the mole equation without having to do any algebra to calculate the number of moles because we know both little m and big M. Okay, so 65 divided by 18.02, okay, will give us our number of moles. About 3 point something?
3.61.
3.61. I'm going to take your word for that. And what are my units?
Moles.
Moles. How important are units?
Very.
Very. Don't forget them on the test. They'll cost you a mark if you forget them. Okay, questions on number 1. Okay. All right, for question number 2, they want to know what is the mass? Mass is little m. They tell us there are 8 moles, so they gave us N. Okay, of magnesium chloride. Okay, what do you suppose people forget to do with this? Drop and swap. Okay, chlorine is a -1. Okay, magnesium is a +2, so we're looking at MgCl2. So that's 24.31 plus 35.45 times 2. Did I get those right?
Yep.
Oops, 35. Okay, 95.21 grams per mole. Okay, so we're looking for little m. That means we are going to have to manipulate this equation by multiplying both sides by big M. Okay, so what we're doing there is we are multiplying the number of moles, so 8 moles, times the mass of 1 mole, 95.21 grams per mole. The moles are going to cancel. I'm going to be left with grams when I do that. Okay, so times 8. 761.68 grams. Okay. Questions on number 2? Right, how many people have done number 3? Okay, let's look at number 3. Okay, so in number 3, it's asking about number of molecules. What am I going to have to include here? Avogadro's number. All right, so we're looking for the number of molecules. Okay, of sodium sulfide, okay, in 200 grams. Okay, Na with S. What do I have to do? Drop and swap, right? Sulfur is a -2, sodium is a +1, so I'm looking at Na2S, right? And so we will have 22.99 plus, or times 2, sorry, times 2, okay, plus 32.07 for the sulfur. Oh. There we go, 78.05 grams per mole. Okay, if I'm going to calculate the number of molecules, what must I calculate first? Number of moles, the thing I don't have, so okay, that's what I should calculate next. That means I just plug numbers into the mole equation, little m over big M, so that'll be 200 grams divided by 78.05 grams per mole. Okay, the grams are going to cancel, I'm going to be left with the number of moles. Okay, so I got 2.56 moles. I'm only going to write that much, but I'm going to keep all those numbers in my calculator. Okay, now that I have the number of moles, how does that and this number here, which is particles per mole, help me? I multiply them together, yeah. Okay, if I know how many moles I have, and I know how many particles are in a mole, then I multiply those kind of numbers together, and I will get the number of particles. In this case, the particles are molecules. Okay, so I will take the number of molecules, okay, and I will take my number of moles, 2.56, keeping all the decimals in my calculator. Okay, moles times Avogadro's number, 6.02. times 10 to the 23 particles per mole. Okay, when I multiply those together, my moles will cancel, and I'll be left with the number of particles. Remember that that number does need to be enclosed in brackets for the purposes of countervening the order of operations. All right, so we have 1.54 times 10 to the 24. Molecules. Okay. How many people have done number 4? I'll give you a little bit more time on number 4. Just so you guys know, where these 4 different sets of mole equation examples came from, they were all old exam questions. Okay, and I've recorded every single one of them. So if you're struggling with this, come see me for help. And it's not a bad idea to try them and watch the videos at home as well, if it's something you're struggling with. But these are exactly what I will ask. Okay, so on number 4 here, okay, they want to know the mass, so we're looking for little m. Okay, they give us the number of molecules. So are we going to need Avogadro's number again? Yes. Okay, 1.2 times 10 to the 25. Okay, and they tell us that it is iron 2 nitrate. So FeNO3, is that ionic?
Yeah.
Yes. This is a -1. The Roman numeral tells me that's a +2. So I need to enclose this in brackets with a 2 outside. Okay, so we've got 55.85. That's our iron. Okay, plus how many nitrogens? 2. So 14.01 times 2. And how many oxygens? 6. Okay, so 55.85 plus 28.02, that's the 2 nitrogens, plus 16 times 6, or 6 oxygens. 179.87 grams per mole. Okay, if I'm going to find mass, I need the number of moles. I know the number of molecules, and I know Avogadro's number, which is the number of molecules in 1 mole, or particles in 1 mole. So, I should be able to do this. If I take the number of molecules and divide that by Avogadro's number, molecules will cancel. I'll be left with moles. Okay. So 1.2 E25 divided by 6.02 E23 tells me I have 19.93 moles. I'm going to keep all those decimals in my calculator, even though I'm too lazy to write them down. Okay. Now I have N. Now I can solve for little m. So I'm going to take the mole equation, n equals little m over big M. I'm going to multiply both sides by big M, okay? And then I'm going to take those numbers, 179.87 grams per mole times 19.93 moles. Okay, moles are going to cancel. I'm going to be left with grams. Okay, and that will be $3,585.45 grams. Okay. Is that one pretty involved? And I threw in like multivalent metal and a polyatomic ion. That required brackets, okay? Like honestly, in Science 10, they don't get harder than that one, all right? That was the most involved that a mole equation question could be, and the most involved that a molar mass calculation could also be. Okay, everyone follow me there? All right. Okay. Give you guys a 5-minute break here, and then I'm going to put some more questions on the board for you guys to practice with that involve really having to glean stuff from the question, because they're stories, not just like this. Hey, I would like you working on questions 7 through 12 for right now. Okay. Again, they're not terribly complex stories, but you do have to read the question carefully to understand what it is asking for. Okay, so really the only one that's a little bit tricky is number 12. Okay, that one you have to do a little bit of thinking and one extra calculation before you can start your mole equation calculations. Okay. So for number 8 here, we know that we start out with 4.5 grams of water. Okay, everybody with me on that? Okay, so 4.5 grams of water. Okay, so can I figure out how many moles of water I have to begin with? Okay, so that's what I want to start with. Okay, I want to figure out the number of moles of water by taking the 4.5 grams of water and dividing it by the molar mass of water. Okay, 18.02. Okay, so 4.5 divided by 18.02. Okay, gives me 0.25 moles. Everybody all right with that? Okay, so I've got 0.25 moles of water, okay, in this reaction. Now, in this reaction, I take water and I decompose it down into hydrogen and oxygen. Agreed? Okay. When I balance that reaction, okay, I have to put a 2 in front of this to balance my hydrogens, okay, and I have to put to balance my oxygens, and a 2 in front of this to balance my hydrogens. Agreed?
Yep.
So that means then that I have the same number of moles of water as I have moles of hydrogen when I'm done. Because they're 1 to 1. They're 2 to 2, but it's still 1 to 1 in the reaction, yes? But I have half as many moles of oxygen according to that reaction. Okay? For every 2 moles of water that I get, I only get 1 mole of oxygen gas. Everybody follow here? That's why, since I got 0.25 moles of water, I must have 0.25 moles of hydrogen gas at the end, and 0.125, half of that, moles of oxygen. Okay? It's about ratios. Okay? If I have this, in my balanced reaction, water and hydrogen have the same coefficient. Okay? What that means, what that can mean is this. If I have 2 moles of water, that'll produce 2 moles of hydrogen gas and 1 mole of oxygen gas. Everyone all right with that? Okay? But it also means if I have 0.25 moles of water, I will get 0.25 moles of hydrogen and half that much oxygen. I'll always get half as many moles of oxygen as I do hydrogen. Okay? Because they're 2 to 1 in the reaction. Okay? It goes back to this. Way back to how can we interpret reactions? Okay? And that was right here on this slide. Okay? When I look at this reaction, it can mean that I have 1 molecule of nitrogen gas, 3 molecules of hydrogen gas, making 3 molecules of nitrogen trihydride. Or it can mean I have 1 mole of nitrogen reacting with 3 moles of hydrogen to produce 2 moles of nitrogen trihydride. Those coefficients can mean either way. Okay? But what it does mean is I get twice as many, okay, nitrogen trihydrides as I do nitrogen gas in terms of moles. Okay? Not in terms of mass, that's not true, okay? But in terms of moles, it is true. Okay? Everybody all right with that idea? All it is about seeing a reaction and the ratios of everything in the reactions. If I get, okay, in that water reaction, if we go back to that, if we go back to that water reaction for a second, okay, if I start out with 2 moles of water, okay, then I get 2 moles of hydrogen, but I only get 1 mole of oxygen, according to the way I've balanced it. Okay? So, that's why the ratios of what I've got here, okay, are the same as the ratios in my reaction. 2, twice as many moles of hydrogen as I get oxygen, okay, or the same number of moles of hydrogen and water, according to the balancing of the reaction. Okay? I got 0.25 moles of water, so I get 0.25 moles of hydrogen. Okay? I could have just as easily written this reaction like this. It wouldn't be proper to write it like this, but it would be true. 0.25 H2O gives 0.25 H2 plus 0.125 O2. Okay? It's still 2 to 2 to 1. Okay? It's still twice as many moles of water as oxygen gas. Okay? And the reason for that is, in water, oxygen is single. When it's by itself, it's double. So I would get half as many moles of it. Same number of particles, but half as many moles, because it's a molecule, not an atom now. Okay? You guys are trying to picture this in terms of mass. Don't picture it in terms of mass. Picture it in terms of the balanced equation. Okay? I'm never going to ask you a question like that in Science 10, but it is the first thing you will do in Chem 20 stoichiometry. And having to be able to figure out, okay, I get twice as much of this as I have that. Okay? All right. Any other ones? Okay. Tomorrow, after I go through the, don't pack up, still lots of time. Tomorrow, after I go through the unit exam review and answer all of your questions, I will also hand back your reactions assignments, okay? They're, the ones I have are marked and entered. And then we'll go through that entire assignment as well, so you can make corrections. And then use that to study them. Okay? All right, keep going there, guys. If you're past that, you can keep going to, let's say, 14. And since we just did 8, we'll move up there. Okay, as I said before, tomorrow we're going to do the unit exam review. So that'll be comprised of me going over the key points of the unit, okay, telling you what the key skills are, okay, talking about what to do with the review package. I will let you know what the format and questions on the test will be, not exactly the questions, but you get the idea, okay? And then taking questions from you. Then we'll go over your reactions assignments, okay, because I'll hand those back and we'll go over those. And then Friday we're going to start biology. Right, so that'll be the plan for tomorrow. So come with questions tomorrow. Okay, if there's something pressing that you need to ask about chemistry, tomorrow would be a great day to do that.